understand what symmetry is, let's draw an isosceles triangle. It's a triangle in which two of its sides are equal. Now let me give you an easy task. You need to think if we can divide this triangle into two parts such that both the parts match exactly when they're folded along a line. How would you divide the triangle if this condition has to be satisfied? Fold it along a line such that both parts formed match exactly. It's easy and I'm sure most of you would have got it right. If we draw a line like this, the condition will be satisfied. Yes, it's a vertical line which divides the triangle into two parts which match exactly when folded along the line. If the part on the right is taken over to the left, we see that they overlap exactly. And that is why this shape is said to be symmetrical. The two parts match exactly when folded along a line. Now let me give you another figure. I draw the isosceles triangle this way and ask you the same question. How would you divide the triangle into two parts such that both the parts match exactly when they are folded along a line? Yes, we can draw a horizontal line like this. We get two parts which match exactly. When one is folded or flipped, it overlaps exactly over the other. Both these lines we see here are called the lines of symmetry or the axes of symmetry. This triangle has a vertical axis of symmetry as this line is vertical, and this one has a horizontal axis of symmetry as this line is horizontal. Now I want you to think about the next question I'm going to ask you. Can a shape have more than one axis of symmetry? If you look at just these two triangles, you would probably say no, because there is no other line which can divide these triangles into two parts that match exactly. But the correct answer is that a shape can have more than one axis of symmetry. Look at this rectangle. These two parallel sides are equal, these two parallel sides are equal, and all four angles measure 90 degrees. It will have a horizontal axis of symmetry like this. When one part is flipped over, it will overlap exactly with the other. And it will also have a vertical symmetry like this. Flip this part and we see the perfect overlap. So a rectangle has a horizontal as well as a vertical line of symmetry. But wait, some of us may be wondering if the diagonals are also the axis of symmetry. Let's say we have a diagonal like this. You can see that folding it along the diagonal does not give us matching parts. You can try this with a page from your notebook. Try and fold it along the diagonal and you will see that the parts do not overlap exactly. Okay, here's another question for you. Can a figure have more than two axes of symmetry? If yes, then which figure? Again, the answer is yes. Take the example of a square. All its sides are equal and all four angles are right angles. It has a horizontal as well as a vertical axis of symmetry just like the rectangle. But for a square, the two diagonals will also be the axis of symmetry. If we fold it along this diagonal, the parts match. And even if we fold it along this diagonal, these two parts overlap exactly. So a square has four axes of symmetry: horizontal, vertical, and the two diagonals. More than four? What if we have a figure like a regular hexagon? A regular hexagon is a closed figure with 6 equal sides and 6 equal angles. How many axes of symmetry does a regular hexagon have? Pause the video and try to arrive at the correct answer. Okay, let's see. The horizontal and the vertical ones are obvious. These two diagonals would also be the axis of symmetry. Do you think there are any more? Yes, the line joining the midpoints of these two sides and the line joining the midpoints of these two sides will also be the axis of symmetry. Folding the figure along any of the lines will give us matching parts, 6 in all. And a circle, on the other hand, has infinite axes of symmetry. No matter how we draw the line passing through the center, the two parts formed will always fold perfectly along that line. Did you know that nature loves symmetry? The best example of symmetry in nature would be that of a human face. It has a vertical axis of symmetry. What we saw in this video is reflectional symmetry. If one part is kept against a mirror, its reflection will give us the other part. Let's say we keep half the hexagon on this side of the mirror, its reflection will give us the other half. Hence it's called reflectional symmetry.